Okay, so for the record, this is 6.2. So I want to do stretches and compressions. And at first we'll just do vertical ones because that'll be easy. Cool? You can figure out the other one. No, not
those compressions, not like a stretcher?
Not chest compressions or stretchers. How did I get Y stuff to change before?
How'd you get Y stuff to change?
Yeah, so remember last time, right? We were doing like shifting, right?
Yeah.
So how did I get stuff to move up? Like what was the...
After the...
Yeah, I did something like after the function I was interested in, right?
After.
So I had something like, okay, so if I wanted a vertical shift, I'd do something like do f of x and then add 3, say. Right?
Cool.
What's that going to do?
Shift up 3.
It's going to take the graph of f and move it up 3. What if you wanted to go down 3?
Well, you probably should put negative 3.
Probably add negative 3 instead, right?
Agreed.
Okay. I want a similar analogy, but I don't want it to just shift. I want it to like smush.
So you can like divide.
That seems like a good idea.
Oh, nice.
Maybe if we divide, that'll like,
Better
I don't know,
you
like-
should bring it down a factor of something, you know?
That'll compress it.
they'll compress it this way?
Inwardly.
Compress.
This way?
Like a hydraulic press.
Yeah, because this way is stretching, and this way is compressing.
Careful. Okay, so these are only going to be vertical stretches and vertical compressions. So let's figure out which one's which.
Well, so you could
Right.
vertically stretch.
So let me propose a vertical stretch. Okay. So a proposed option for a vertical stretch would be something like, oh, I don't know. If I, let's see, you guys think it's multiplication? Multiply by a positive number.
After the function.
Greater than 1.
Greater than 1, right.
Oh, good call, you jerks. So it has to be a positive number bigger than 1.
Yeah.
So if you multiply by a positive number bigger than 1 after the rule, or after the function, that'll give you your vertical stretch. Let's check that. I think we can check that. So if I tried, let's see, let's take f of x is, what's your favorite function?
Mx plus b.
Cool.
Dx plus 4.
Let's take 3 times x plus 4.
Yes.
That wasn't what it said.
What did it say?
3x plus 4.
Well, that's boring.
12.
I'm not doing that. The reason I'm not doing that is that's a composite of 2 rules.
Yeah.
What? You know.
Well, because that would be different.
Because that would be both a multiplication by a number and a shift. And the rule you're talking about is the rule y equals x, which is a boring rule.
Yeah.
Okay? So I want to try this one, which is take 3 and multiply by x plus 4. So what's the base rule I'm thinking of here?
X plus 4.
Yeah, I'm kind of thinking of this is a shift of x plus 4, which is itself a shift of x, right?
Yeah.
Okay, but let me just assume, I'm going to assume x plus 4 is my rule, my function I know the graph of. That looks like what?
X plus 4?
Yeah.
Well,
X equals y. Make that
exactly.
Y equals x. Shit. Right, got a 4, slope of 1.
Yeah.
Okay?
Yeah.
Okay. Now, if I multiply by 3 after I apply that, this should stretch this thing out, right?
Right.
You guys with that?
So
Yeah, but it also moves it. Like, hang on. I gotta go back to algebra land for a second. What is this algebraically?
3x plus 12.
Okay. So if that's 3x plus 12, how do you get a picture of 3x plus 12?
Well, you have a slope of 3 and you hit 12 on the y-axis.
Yeah, so you need to go up 12 first. So 1, 2, 3, 4. Okay?
Okay.
And slope of 3,
So
right?
you go up 3 and down.
So if I go
3,
back 1 and down 3.
Yeah.
So I get some kind of line like this.
Uh-huh.
That's it.
That was
That's
a
it,
vertical.
stretch. Yeah.
Definitely stretch.
Yeah,
Yeah.
seems like it definitely got stretched out.
Mhm.
Keep in mind that's a stretch not just in terms of slope, right? But this is a stretch away from the y or from the x-axis, right?
Yeah.
You guys all see that?
Oh,
Okay.
so it brings it in closer on the left side and farther away on the right.
Yeah, so that's why I don't like using lines for this.
Is the X-
Because a vertical stretch on a line like this is pretty close to a horizontal compression.
Is the x-intercept the same on both of those lines?
I don't know. Let's see.
I don't think so, because the slope.
So where's the, do you guys remember how x-intercepts work?
You make y.
Yeah, equals
Zero.
zero.
Make the output 0. So we're looking for, on this one, the x-intercept is at 0 is 3 times x minus 4.
So x is negative.
Oh, wait, sorry. That was just supposed to be x plus 4.
So x is negative 4.
So x is negative 4. That's here. And then after I multiply it, I get the
totally right.
same thing, right?
Yeah, so it is still negative 4.
Okay, so why is that the case? Like, why does that jive with my idea of
Because
Stretching.
it's closer to the x-axis before it's stretched, so it's like it goes. It's proportional. Like,
how about it? Yeah, how about it's on the x-axis, and all this is doing is stretching away from the x-axis.
Yeah,
Right. So if it's on the x-axis and you stretch away, well,
it's just pivoting.
it's still on the x-axis.
Yeah, it's like a pivot point.
You guys see that? Does that make any sense at all? Should we try this with a better function?
Well, if you drew the same distance of the above the x and below the x, it might look better.
Definitely it would.
I think it would look better.
So the x is stretching to like keep up with the slope.
Another way you can think about this is that you're just counting 3 of the new x units for 1 of the old ones.
Yeah. Okay.
Right. So the classic multiply by 10 thing would be, well, okay, a classic thing would be to move from quarts to gallons, or from gallons to quarts maybe, and you would just multiply whatever you had by 4. Right, to move from gallons to quarts.
Right.
So it's just counting in more bits basically by this multiplication. Let me try another example for kicks. So, what if I took f of x is x squared and g of x is 4x squared?
And you're on defined as f.
No, easier. I'm just trying to figure out how this, how did you obtain the graph of g from the graph of f?
You multiply by 4.
There's a multiply by 4 after you got the y. So x squared looks like a nice chill parabola. It goes through some points here. What are these points here?
1, 1.
1 and
Those are probably 1, 1, and
negative 1, 1.
negative 1, comma 1. It also goes through this point here, which is
0, 0.
0, 0. And maybe let's peg one more point. So up here it goes through
2, 4. 2 and 4.
2, 4.
Negative 2, 4.
Okay, so how about 4x squared?
Well, you just take all your x values. Divide by 4.
No.
No, all your y values.
Take all your y values and multiply them by 4, right? So this is going to go through 0, 0 still.
1, 4.
It's going to go through 1, 4.
And then 2 times 4. 4 times 4 is
2, 6.
It's going to go through minus 1, 4. And way the heck up here, it's going to go through 2, comma 16. And otherwise, oh gosh, that was just bad drawing. And otherwise, it's still a parabola, right? It's just a much steeper parabola.
Agreed. It's like 4 times.
You guys with us? Okay, so you guys already spotted this thing about bigger than 1. What happens if you multiply by a number smaller than 1?
Then you're dividing by you like you're just making your number smaller.
Yeah. So how would you phrase that? That would be a vertical compression.
Vertical comprehension.
And to get a vertical compression, you would multiply by a positive number
Between 0 and 1.
Nice. Right?
After the function.
After the function. If you multiply it before the function, what's going to happen?
You're just going to have
You're
really.
gonna get a horizontal compression.
Yeah, you'd really like for it to be a horizontal compression,
Horizontal stretch.
but there's no justice at all in the world, so it's a horizontal stretch.
So,
One way we could see that here
That makes sense though.
is that
Because
g of x, right,
you take the x value.
is 4x squared, right? And that got a vertical stretch.
Yeah.
4x squared is also 2x quantity squared, right?
oh yeah.
So that's me multiplying by a number bigger than 1 before the rule, right?
Yes.
So if there was justice in the world, that would be a horizontal stretch, right?
But
But it's really clear that this picture isn't a horizontal stretch of this one. It's a horizontal compression. So keep in mind, these things act backwards for x value stuff. Guys cool with that?
Yeah.
So just to clarify, horizontal compression for that.
So that one is a horizontal compression, yes. So maybe I should write those down while I'm at it. So to write those down, that would be a horizontal stretch. You would multiply by a positive number. So to get horizontal stretch, you need to multiply by a positive number
Before the function. 0 and 1.
between 0 and 1 before the rule. So the before the rule part is making it an x thing, and the size of that number is making that stretch versus compression.
Right.
So between, because your vertical stretch and vertical compression, your y's are changing. Horizontal stretch, your y got changed. Horizontal compression, your y got changed. Horizontal stretch, your y gets changed. So the x just is the same every single time.
The x is the same.
No, on the horizontal, you're you're changing your input. You're messing with the input.
Yeah, so horizontal things, you're going to be messing with the inputs that give specified
So
outputs.
it's like here's your function.
And
here's my
vertical
function,
things,
and
you're messing with the outputs that are given by specified inputs.
Yeah.
Right, but for the horizontal, even though you're messing with your inputs, you didn't change your input.
So I didn't change the inputs that I was kind of drawing, right?
Okay.
But if I thought about those as compressions, right? Remember that 1 was, the original point I was talking about was 1 comma 1.
Right.
This isn't 1 comma 1 anymore.
Okay, okay.
Right? To
cool.
get 1 out, you'd put in a quarter or something.
Okay, so with your horizontal,
Or
you're
a half,
messing with
really.
your axis.
Yeah, so the horizontal ones you're messing with the x's, and the vertical ones you're messing with the y's, because of where they happen, right?
Right.
If you do something before you do the function, you're really playing with the x's. If you do something after, you're really playing with the y's. And then you guys just need to know that anytime you're doing y stuff, it acts like you think it should, and anytime you're doing x stuff, it acts backwards. Okay? So what's your last one here? To make a horizontal compression, you
Multiply by a
multiply.
positive number larger than 1 before the function.
Multiply by a positive number
Yep.
bigger than 1 before the rule.
Yeah, take it and horizontal composite.
Cool? Okay, so next time we're going to do combinations thereof. Cool? And again, the things you should remember are the y's act like you think they should, and the x's are backwards.
there's
Cool.
no justice in the
because there's no justice in the world.